Hello everyone. So we are discussing the basic definitions. So up to water content we have discussed. Now we are discussing the another basic definition, that is void ratio. So void ratio is generally denoted by E. So E can be expressed as E is equal to volume of voids to the volume of solids. Volume of voids to the volume of solids. In every basic definition, what we are doing, first we are defining that definition, and then we are expressing the minimum limit and the maximum limit. So E can be greater than 0. E can be greater than 0. It will not be is equal to 0 because volume of voids and volume of solids can never be equal. So that is why it is not equal to 1. And also if the volume of voids keeps on increasing, then this upper limit will goes on increasing, so it can be greater than 0. It will never be equal to 0. Why? Because volume of voids can never be 0. So this is one of the important point. Void ratio can be expressed as volume of voids to the volume of solids. Since volume of voids can never be 0, so that is why the numerator can never be 0. But when the volume of voids keeps on increasing, E value also keeps on increasing. That is why E greater than 0. So then there rises a question whether void ratio is more in a coarse grained soil or a fine grained soil. So the individual void size is more in the individual void size is more in coarse grained soil. CGS means coarse grained soil. The individual void size is more in coarse grained soil, but whereas the void ratio E is generally more in fine grained soil. When you take individual coarse grained particles, when you take coarse grained soil, the individual voids, that means now from one particle to one particle there will be more void. But when you compare the void ratio, generally for fine grained soils it is more than coarse grained soil. This can be explained as, so when you take rice particles, so when you see, there will be no cohesion between one rice particle to one rice particle. For example, this is the bowl. In this you have taken some rice particles. So I am just comparing these rice particles with coarse grained soil, since there will not be any cohesion. Let us suppose this is the let us say weight. This is suppose the volume. So this is nothing but coarse grained soil. Now grind it. After grinding, what will happen? So there will be cohesion. This is a fine grained soil. So after grinding, what is happening? This volume is increasing. So if the volume is increasing, then volume of voids will also increase. So if you compare these rice particles with these rice particles, in this there will be no cohesion, but after grinding there will be cohesion. So this is just as an example that how the void ratio will be more in fine grained soil than in coarse grained soil. The individual void size is more in coarse grained soil, but whereas the void ratio of fine grained soil is generally more than coarse grained soil. So E of clay, there are some standard values. E of clay is greater than 0.8. The void ratio of clay is greater than 0.8. When you compare the void ratio of sand lies between 0.5 to 0.7, 0.5 to 0.7. And also the maximum void ratio is equal to 0.91. The minimum void ratio is equal to 0.35. So this maximum void ratio will occur in simple packing structure, simple packing of uniformly sized spherical particles. USSP means uniformly sized spherical particles. This structure you can Google it. So this will occur in minimum occur in face centered cubic packing. Face centered cubic packing. Or else I'll show how this simple packing of structure will look like and face centered cubic packing will look like. Simple packing is nothing but, so there lies one particle below the other particle is nothing but simple packing. This is simple packing. So this is in this structure we can find maximum void ratio. So face centered cubic packing is nothing but, so this is the first layer. Second layer will start from this layer. So this is the face centered cubic packing. If you draw the layer by layer, then you can clearly identify the difference between simple packing and face centered cubic packing. So what we have discussed, so we started with the definition of void ratio, and then we have seen the definition and the minimum limit and maximum limit. So in which kind of particles void ratio is more, and the maximum void ratio will be how much, and it will occur in which type of packing, and minimum void ratio will be how much. So this is all about void ratio, and in the next class we can discuss about the porosity. So thanks for watching. For more videos please subscribe to my channel.